Hello everyone, this is Vishnu, and my DAA Tech Talk topic is on schematic graphs of traffic sensors for intelligent vehicle systems, which are nothing but the autonomous vehicle systems. And DAA stands for Design Analysis of Aeronautical. So moving on, why do we require traffic scene training anyways? So for the existing AI systems, autonomous vehicle systems, this traffic may be viewed as a metric which is extremely difficult to anticipate. It which is traffic is something which is most likely where the AI could fail to predict. So the sudden movement of cars near an AI-controlled automobile might complicate the situation. The AI needs to focus on the car, or based on that, the AI model uh, needs to alter itself from time to time, which leads to memory and hardware intensive or processor intensive calculations. Uh, and vehicles around the system are not operated by another system, so but by a human. In the worst case situations, the people their actions may lead to our AI to get confused and proceed a wrong operation, which may cost a lot. It may be anything like an accident or anything way more worse than that, or getting your car damaged. So how are we going to get there? I mean, how are we going to solve this problem? So to achieve this, the most unpredictable uh, traffic, one way is to train our model in such a way that, like in a simulated conditions, the AI model needs to be trained, and with respect to time, like with respect to the performance of the AI model, the aggressiveness will be increased. So by simulating neural networks specific to the required environments, where a neural network which is completely dedicated to perform these kind of operations uh, will be uh, will be there, and the outputs which are generated by this neural network are fed back into the main network as a form of a bias. So bias is in the form where it may be false, then this bias will make it to be true. And schematic graphs can aid with visual data segmentation, as we are talking now about the semantic graphs is the main topic, and this can aid with visual data segmentation. Segmentation in the sense dividing the visual data into groups. So as you can see in this image, as you can see in this image, each and everything has been segmented. As there's a van which is in blue color over here, and a few cars which are parked and which are coming in the opposite lane are being detected or are been marked in blue color, and trees, the vegetation, and the buildings are in the green, gray, and light blue colors, and the road is represented in pink color. So this is not a very perfect model. As you can see, there is so much of noise, and the edges are also not clear enough. So we can say that it's not that good of an algorithm, but it serves a purpose. But still, there will be chances where AI may fail to understand and perform a right operation. So the next image is much more clear, as there is not much of a noise. There's not much noise, and it's clean, and the data has been segmented correctly, properly. So over here we can have a look at riders, 2 to 3 riders and pedestrians and a car over here, and the model has predicted segmented correctly. Um, we can say 80% accurate or 90, we can say, because the road is not clear and it didn't predict a vehicle, but it did predict a man over there, but there's no man or person over there. And the second picture as well, it did detect the bicyclist, but there is a car, but it didn't predict it as a person. So moving on, it did predict there are traffic lights and there are pedestrians and road. As you can see, the middle images are with noise. They did what they have to do, but there's a lot of noise which is completely useless for a AI model to correctly do its thing, to perform its tasks. So here the data is much more clean compared to the data, previous data, and this new data will be fed into the system, and then it will predict what to do and when and where and when and where um, or where exactly an object is there. So based on that, it will predict and it will do its operations. And in this big picture, we can have a look at the road, which has been segmented correct with edge detection, with proper edge detection. We can say 90%, 90 to 93, maybe, and it did predict segmented the road, buildings, vegetation, and pedestrians and cyclists, and a bus as well. So this is how a semantic graph is going to look like. Moving on. So what makes semantic graphs layer in autonomous vehicle development? So as I was seen in this um, pictures, that it did segment um, different kind of objects really well, where in previous models, in previous generation AI models, canny edge detection is being used, where the edges are being detected and noise has been normalized with them. And with the help of that, we used to evaluate uh, where is the road, and for that, we had to uh, remove certain part of the area of the visual data, which will be fed into the system, where it may not uh, confuse itself in predicting which is a road and what is a traffic light or any speed indicator, etc. So um, these autonomous systems, in the sense these semantic graphs, can evaluate the object size and area, and can also initiate appropriate countermeasures. If there's a car, then the AI should take a big turn, or it should stop. Or if it's a person, it may stop or it may dodge with respect to the speed of the vehicle with where the AI is present. So with the help of we can evaluate what's the size and the area of a object which is present in front of the car or the AI vehicle. So these graphs make edge detection easier with the help of more research. Um, this will be possible, where edge detection is easier and it's very accurate. Whereas in can edge detection, where this, as I said earlier, can edge was used in the previous versions so as to predict the edges of the road or of an edges which are present in a visual data. So that's it, and thank you.